Good afternoon, I am Mr. Ish. Thank you for joining me for this video. We're looking here at partial fractions decomposition. It's a pre-calculus topic, something you need to know if you're going to do ever pre-calculus or advanced math. Exactly what is this procedure? If you have a rational function and you wanted to determine what were the partial fractions which when they added up gave you that rational function, this is the technique you have to utilize. Consider this as a rational function. This right here is like one of the easiest cases. What were the partial fractions when you added them up? You ended up over here. Think about separating everything across this minus sign here in the numerator, and you would have x over 2 minus x plus minus 1 over 2 minus x. If you add both of these, you'll end up exactly here. Think about it. Common denominator, you'll have x minus 1 and you're done. But this here is the very simplest of cases. You want to use partial fractions decomposition when you have something more here in the denominator and something you can do with. And you also want to utilize it ideally when the order of exponents here in the denominator is higher than that in the numerator. Look at the exponent here in the denominator, you have to the power of 1. Here in the numerator, you have to the power of 1. You want to ideally use it for situations where the denominator exponent order is higher than that of the numerator. So utilize it for those cases. Anyhow, partial fraction decomposition is a technique for breaking down a rational function into its parts. Those parts add up and give you back what you started with. Partial fractions decomposition can get quite complicated, but in this video we're looking at only simple cases because I want you to know at least the technique. Let's look at one example, then we'll look at two questions, and the best way to learn this is through practice and by watching someone do it, and then you replicate it, you understand what was involved. Consider this right here as your rational function and you want to determine the partial fractions by decomposing it. The first step you need to do is always simplify your denominator in terms of factoring it out. Look here, the exponent here is 2, here it's 1, so this is ideal case to use this technique. You can factor out the denominator into x minus 1 and into x plus 1. When you make your factors here in the denominator, that will right there tell you how many items you have or how many partial fractions you have. I have one factor here, therefore I must have two partial fractions which will come. The partial fractions are always in an adding format or an add format. On top of one you'll put one letter, and on top of the other you'll put the other letter, and on the bottom you'll put each of the separate factors. You see this and this. Alright? You don't need to do anything with this just yet. And now you'll do a common denominator of what you have over there, x minus 1, and then you have x plus 1. Then you'll see how much each goes in the other. X minus 1 goes in this x plus 1 times, and you'll multiply it by its numerator, a times x plus 1. This goes in here x minus 1 times, so you'll do b times x minus 1. Right? Now you can equal this exactly what you have on the top, your original numerator. Open up this stuff right here, and if you want you can eliminate this denominator because you won't need it anymore. Now open up everything here. You have ax plus a plus bx minus b is equal to minus x plus 2. I just rewrote it, there's nothing wrong. Now look for your common terms. You have a linear term, meaning linear variables. Then you have a constant, and a constant, and put them together. Only their coefficients. I have ax plus bx equals minus x. I'm only looking at their coefficients. You have a plus b is equal to minus 1. See? A, b, and minus 1. My other equation are the constants. I have a minus b and a 2. A minus b equals 2. You can do matrix algebra, you can do substitution, elimination, but you have to find the values of this a and b, the systems of linear equation, you have to find that. I'll do elimination. A plus b equals minus 1 and a minus b equals 2. I'll add them up. I have a 2a, this cancels out, is equal to a1, right? A is equal to 1 over 2. Now I've determined a is equal to 1 over 2, I can put them in any of these and solve for b. You can put here half. B is equal to minus 1 minus half, you'll have a minus 3 over 2. So that right there is your value. Now you've determined a and b, you have to plug these values a and b right here. I have a value here a is equal to 1 over 2. I have a value b is equal to minus 3 over 2, right? Minus 3 over 2. Now we're very close to being done. Remember, this is all us determining what were the partial fractions that gave you this. Now just write this in a better format. You'll have 1 divided by 2 into x minus 1 plus minus 3 over 2 into x plus 1, and here it is. These are your partial fractions. 1 divided by 2 times x minus 1 plus minus 3 divided by 2 times x plus 1. If you want, you can write this as this. If you were to do the fraction algebra of all of this, you'll end up exactly over here. So this question has been done. So you've seen what the technique is. Now let's do some two questions over here. We look at this as our first question. We have to decompose this rational function. It's not hard, but start by writing the numerator and then start by factoring this out. This is x plus 3 and x plus 1. When you factor it out, the number of factors will tell you how many items you have or how many partial fractions you have. I have 2 factors here. If you were to open this up, you'll get that. Therefore, I must have 2 terms, and those 2 terms must add with each other, and they'll each utilize one of these factors. On one, I'll put a, on the other, I'll put b. You'll have to do a common denominator here, x plus 3, x plus 1, then you'll see how many each goes in the other. X plus 3 goes in here, x plus 1 times, so I have a times x plus 1. Then I have b times x plus 3. You can erase the denominator, you don't have to, but you can, and all of this will equal your original numerator, 5 plus x. Open this up, you have ax plus a plus bx plus 3b is equal to 5 plus x. Why are you doing all of this? To determine your systems of linear equations from where you will determine the values of a and b, or whatever letters you had. Look at your linear terms, ax, bx, and x. I have a plus b is equal to 1, and you always look at their coefficients. I have a, b, and a 1. Then look at my constants. I have a plus 3b equals 5, so I'll just use a plus 3b is equal to 5. Now you have to do some elimination. A plus b equals 1 and a plus 3b is equal to 5. You can minus this will cancel out. You'll have a minus 2b is equal to minus 4 and b is equal to 2. If b is equal to 2, based on this right here, a must be equal to what? Minus 1, right? Now you've gotten your values of b and a. A here is equal to minus 1, so you put minus 1 here. B is equal to 2, and you put 2 over here, and this right here is your answer. This right here is your decomposed partial fraction of this rational function. If you were to add this using fraction algebra, you'll end up right over here. So this question has been done. Our second and last question for this video is this. Remember, we're looking at only simple cases over here where everything's routine. There's so many varieties here that things can get complex, but you always start learning simple, then you go hard. Write your numerator as you see it, take your denominator and factor it out. You have to factor it out into as many factors as you can. If you had a rational function which can be simplified where something can cancel from the top and the bottom, the numerator and denominator, you must cancel those things out. But we're not looking at cases like that because here we're learning the technique. But you must always start after simplifying your rational function. If something could have been cancelled out, you would cancel it out and then you would proceed from there. Anyhow, you have 2 factors here, therefore you must have 2 terms. One will have one factor and the other one will have the other factor, denominator factors, but they'll always add with each other. You can put a and a b. You must do a common denominator here, x minus 2 and x plus 2, and then you must see how much each goes in the other. X minus 2 goes in that, x plus 2 times, so a times x plus 2 plus b will go in here, x minus 2 times. Alright, and as I always do, I erase this because it makes things clean. Open this up. All of this will actually equal to 3 minus x, your original numerator. Now I'll open it up here. ax plus 2a plus bx minus 2b is equal to 3 minus x. Look for your linear terms here, here, and your constant terms here. Now look at the coefficients of each. I have a plus b is equal to minus 1, and my other one is 2a minus 2b is equal to 3. Now we can just do elimination. When things get more complex with multiple things here, then you might have to do matrix algebra, but here we don't. Alright, we'll do elimination. I'll multiply here everything by 2. I'll have a 2a plus 2b is equal to minus 2. Here I'll have a 2a minus 2b is equal to 3. I'll add them up. This cancels out. I have a 4a is equal to 1. A is equal to 1 over 4. Therefore b is equal to what? Look at any of these equations. I'll look at right here. If a is equal to 1 over 4, b is equal to minus 1 over 4, which is minus 5 over 4. So we've determined our a and b values right here. You just take them and you put them right over here, and then you can adjust your answer to make it look good. A was equal to a 1 over 4, b is equal to minus 5 over 4. But I want to make it look good, so I have to erase it and make it look good and show you what that good answer looks like. The good decomposed partial fractions. It would be 1 over 4 times x minus 2, and I can bring that minus here. 5 over 4 times x plus 2. This is my decomposed partial fractions of this rational function. If you do the fraction algebra here, you should end up right here. And now you've seen the technique for simple partial fractions decomposition. Over the successive videos, whenever I present them, we'll make it slightly harder. We'll show you the varieties that arise and you can learn all of that. Thank you for watching. Have a nice day.